Esteemed colleagues, my name is Bálint Kovács, and today it is my pleasure to present to you our research on MR.Sketch, immediate 3D sketching via mixed reality drawing canvases. These findings are an intermediate result of the ongoing research project F77, SFB, Advanced Computational Design, founded by the Austrian science fund FWF. Our research focuses on creating computational tools for early architectural design. One of the most fundamental tools for early architectural design is sketching. To define our research goal, first, we would like to provide a definition of sketching. Sketching is not limited to the colloquial notion of freehand drawing on paper. Sketching is fundamentally a means of communication, communicating ideas to others and communicating ideas to oneself. Thus, sketching is thinking about shape, form, and the realization of thereof. Thus, sketching, by definition, has to be fast and immediate. Sketching is not limited to a specific technique and must not be limited by its tools. This notion leads to our research question. How can we transfer the immediacy required for sketching to the realm of creating sketches directly in 3 dimensions? There are multiple paradigms on how to tackle this problem. VR-based methods using 6 DOF track devices provide precise spatial control, but lack the haptic feedback of traditional sketching techniques. Projective 2D to 3D methods provide the user with the familiar feel of analog techniques, but introduce an intermediate decoupled step, defining the drawing canvas onto which sketched lines can be projected. This deprives the artist user of the immediacy required for unhindered ideation. There are different proposed solutions to canvas definition in the related literature, ranging from switching between predefined surfaces through using reference images to extract canvas geometry to in-air canvas definition, etc. What we can surmise from the related literature is that canvas definition and actual sketching are decoupled, separate work steps. By having to define the drawing canvas, the free flow of ideation is compromised. To remedy this, we propose a new way of drawing canvas manipulation for 2D to 3D projective sketching: viewport-attached canvases. In our method, the canvas is always attached to the camera viewport in a fixed, relative pose. In contrast to methods of explicit canvas control, the definition of the drawing canvas does not happen in separate steps. Instead, the user only controls the camera viewport in space, and the attached drawing canvas follows this movement. This mode of canvas handling provides a substantial improvement in immediacy and accessibility, as there is no need for the user to deal with any aspect of the user interface or to think about performing the action of canvas definition at all. The visualization of the drawing canvas is of prime relevance in order to support the user in accurately perceiving and interpreting its spatial configuration. We enhance the capabilities of our method by providing 2 drawing canvas visualization approaches. First, a grid visualization that can be used in fully and semi-transparent mode to provide a notion of what parts of the scene are in front and what parts of the scene are behind the canvas. And an intersection visualization to show where the drawing canvas intersects objects in the scene. These visualization techniques affect real and virtual objects alike and can be used in any combination. We implemented them via Unity's URP scriptable rendering pipeline. We implemented our technique in an augmented and mixed reality context. Moving the camera is done by using a manual movement of the tablet or smartphone. A LiDAR and IMU sensor supported inside-out tracking is used to determine the spatial pose of the device. To achieve this, we targeted our experimental implementation towards the Apple iPad Pro tablet device that exposes these hardware features via the integration of Apple's AR kit in Unity AR Foundation. The implementation makes use of Unity's AR Pose driver and AR Camera Manager to achieve the 6 degrees of freedom tracking of the tablet's spatial position and orientation. The broader context of our research is early architectural design. The integrative mixed reality sketching application MR.Sketch is a testbed for evaluating experimental concepts. These include, to name a few, iterative design, where a new drawing canvas is created from previous sketches and reused to refine a design by drawing on it incrementally. Also, network data streaming, to create real-time data exchange interfaces to industry-standard AEC applications. This enables communication and collaboration between AEC professionals at the earliest stages of design. The results of analysis performed in various parametric design and engineering simulation software are also fed back and visualized in our application. To assess the improvements of our proposed technique on the sketching experience, we conducted a user study with 16 participants. The goal of the study was to compare the viewport-attached mixed reality drawing canvases to a two-step canvas control model on their appropriateness for the sketching is thinking paradigm. To allow a direct comparison between a two-step canvas handling and our proposed technique, we have implemented a sketching mode where the user can directly manipulate the drawing canvas. This mode acts as a stand-in for the generalized idea of drawing canvas handling as described in related works, in which creating, configuring and posing the drawing canvas and sketching the strokes are two distinct work steps. We opted for a within-subject study design with participants recruited from the general public. All participants had to perform a direct comparison of the two canvas handling approaches by completing 4 fixed and 1 creative sketching task. We recorded the sketching time with special regard to the time it takes to start sketching, as well as qualitative user feedback. The results of the study indicate that users strongly prefer our viewport-attached canvas handling method, shown in red and indicated with VA, to the two-steps canvas configuration approach, shown in blue and indicated with CC. Users had to spend less time thinking about operating the tool and had a more immediate sketching and ideation experience. Both the speed of drawing and the user preference for these methods support this conclusion. Furthermore, regardless of the canvas handling method, users were vocal about the positive effects of our canvas visualizations on spatial competence and understanding. We have presented a technique based on projective 2D to 3D sketching, introducing the combination of viewport-attached drawing canvas handling with the utilization of transparent or semi-transparent grid and intersection visualization of the drawing canvas. In its development, we have followed the design principle that defines the goals of sketching explicitly within the sketching is thinking paradigm, as opposed to a CAD or 3D modeling approach. As a result, our method sacrifices drawing precision in favor of a more immediate sketching experience. Other techniques described in related literature propose yet more steps or automated tools to achieve precise interconnectedness of 3D sketch lines. In contrast, our technique enables the designer to concentrate more on the form-finding ideation rather than on the features and the operation of the tool. Our technique enables an immediate, intuitive, unobstructed interaction that translates the characteristics of traditional freehand drawing into the context of 3D sketching. In the future, we aim to translate the application of the sketching is thinking paradigm to different sketching techniques. As such, we plan to develop new AR, VR and MR methods for digital sculpting interactions and ready-made based creative processes such as collage and montage that ensures immediacy and unhindered form-finding work. We plan to incorporate the temporal aspect of sketching, such as stroke dynamics, and the use of sketching techniques for kinetic architecture. We will conceptualize and develop further architectural use cases and extend our evaluation efforts to multi-user and cooperative sketching workspaces.